All right, composite functions. So composite functions are functions composed of other functions. So you can see that here we have placed a function in another function. So when you see this little circle, this means composite. So it's saying f is composed of g of x, which means you can write it like this. So if we have g, for this next one, is composed of f of x, then we would write it as g f of x. And so what that means is that f of x on the inside is what we need to find first. So f of x is what we have to find first. And so if we search up here, we see there's f of x. And so f of x is equal to x squared minus 4. So we're going to take our f of x and replace it with x squared minus 4. So this would become g of, and then x squared minus 4. Now we have our function that we can actually plug in. So our g here is 3x minus 4. So if you remember with functions, we take whatever's here and we replace it with parentheses. So this would become 3, sorry, wrong color. This would become 3 parentheses minus 4. So all I did was replace the x here with a parenthesis, just like we've done with normal functions. And then now we plug in x squared minus 4, and we have found our composite function. We still have a little bit of simplifying to do. So if we distribute that 3, we get 3x squared minus 12 minus 4. And then that would give us 3x squared minus 16. All right, so let's try it again. Now we have f is composed of p of x. So again, we'll put that one in green. Like that. And so we would have f of, and then now we grab our p of x. Our p of x is the square root of 4 minus x squared. Again, green. All right, let me move this one a little bit out of the way here. We'll just shrink it a bit. There we go. All right, so now this would equal, and now we're starting with the f function, and f of x is equal to x squared minus 4. So that would be parentheses squared minus 4. So parentheses squared minus 4 is our function, and our input is square root of 4 minus x. And there we go. There's our composite function. So you can see that we are taking one function and plugging it into the other function. This is why they are composite functions. That one function is composed. So we're taking this, plugging it into g, and then plugging that back in to f. So we're working our way back. We're starting with the x, and so we would get p of x. And then we take the p of x and we plug it in the f. And here we go. So now if we square root and square cancel, giving us 4 minus x minus 4, which would give us just negative x. Oops, simple little error there. There's an x squared on there. So it's really negative x squared. So yeah, that was 4 minus x squared. That would be an x squared, so x squared. All right, so that's what we do when we have x, some random variable. And we could now, if you wanted to find p of f composed of p of 2, we could just plug 2 in and find out what it is. But what if you're given the number right off the bat, right from the beginning? What that means is we're going to take p2 and plug it into p. And then from there, and let's put that one in green. So we're going to go 2 into p, and then that into g. So it's just like before. This is really g composed of p of 2. So the first thing we need to find is p of 2. See, if you look back at our functions up there, there's no p of 2. There's p of x. And so that's what we're going to use. P of x is equal to the square root of 4 minus x squared. So that would be, again, square root 4 minus parentheses squared. So square root 4 minus parentheses squared. And then our input here, I'm actually going to change to red so that you can see it. That's a 2. Let's make this a little bigger. 2. Now when we plug it in, it would look like this. So there we go. It's like Christmas. Okay. So if we simplify this, that's 4 take away 4, which is 0. So now this would become g of 0. Just like that. So our p of 2 is 0. We can now replace it with 0. So just like I was saying, this process, we're taking 2, plugging it into p. We get 0. we're now taking that 0 and we're plugging it in to G. So you're just working your way back. So now G would be 3 parentheses minus 4. We plug in the 0 and we get negative 4. So G composed of P of 2 is negative 4. Okay, so let's do some more examples. So again, we're going to first plug 0 into G and find out what it gives us. So this would become F of, or F composed of, G of 0, like that. So we're going to first plug the 0 into the G. Okay, so our G of x is 3x minus 4. So that would become 3 parentheses minus 4. We substitute the 0. It gives us negative 4. So plugging in the 0 gave us negative 4. So that's what we're going to now plug in to the next one. So this would be f of negative 4. When we go back and look at our f function, that would be parentheses squared minus 4. So parentheses squared minus 4. Just so the colors are correct here, let's put that one back in green. Negative 4. And so that would become 16, take away 4, which is 12. All right, since we're now on a roll, let's keep going. This again would become f composed of P composed of, or not composed of, with negative 1. So it's f composed of P of negative 1. It's f composed of P of negative 1. And so it looks like that. So again, we're taking the negative 1 and plugging it into P. It will then give us a number that we then plug into f. So let's start with P of negative 1. Let's go back up. P of negative 1 is the square root of 4. So we put parentheses. I'm going to put the negative 1 there. Let's verify it is, since we had to. Let's just make it a little smaller. There we go. So it's the square root of 4 minus x squared. So it would be the square root of 4 minus parentheses squared. We're inputting negative 1. So let's plug in the negative 1. And so that would become the square root. Oops, wrong color again. Square root of 4 minus 1, which is the square root of 3. So this becomes f square root of 3, should be green. And so that's what we're plugging in to the next one. We're plugging in square root of 3. Okay. So now we go back to f, and f is x parentheses squared minus 4. And we input the square root of 3. And so square root of 3 squared is, square root of 3 squared is just 3. So 3 minus 4 is negative 1. Okay, so these are composite functions, and they work the same way. So if we had f composed of g, composed of f, composed of p of 2, our first thing would be to take this and plug it into p. It would give us a number, which we would then plug into f, which would give us a number, which we would plug into g, which would give us a number, which we plug into f. So it would just be this working your way down. It would be p of 2 is equal to, and then we would do f of is equal to, and then we do g of is equal to, and then f of is equal to, and we get an answer. So if we do p of 2, plugging into would be 4 minus 4, which is 0. And so then we would take the 0 and we'd plug it into f. So 0 minus 4 is negative 4. And so that is what we would then plug into g, which would be negative 12 minus 4, which is negative 16. And then we plug that negative 16 into f, which would be 16 squared, which is 256 minus 4 is 252. So you're just working your way back. This came out to be 0, which we plugged into p, which was negative 4, which we plugged into g, which was negative 16. And then we got, oops, I missed a number. We plugged 2 into that, which was 0, which was negative 4, which was negative 16, and then it outputted 252. So you're just working your way back through your composite functions. Now, if any of these numbers are wrong, you can fix them. It's not one of our examples. It's just the idea. I did that really quickly. All right, so same basic idea here. This would become f composed of g of 2. So what that means is we need to find g of 2. And you have a table here. These are x values, and these are the outputs. So if I had this right here, this means x is equal to 2. So my x is equal to 2 means my g of 2 would be 4. So this becomes f of 4. And then f of 4 would be 1. There you go. Let's try it again. So this would become f composed of g of 4. Okay, so 4 is our x, so we go to 4. Our g of 4 is 2. And then now we're on to the f table. So we go over to f. F of 2 is 3. So I want you to try the next ones. I want you to hit pause now in the video and see if you can figure out what these composite functions are. Okay? Hit pause now. Okay, so you should have gotten this for your answers. And the last one was just to throw you off. That's not a composite, that's a subtraction. So this would just become f of 3, g of 3. So f of 3 is 2, g of 3 is 3, so 2 take away 3 is -1. All right, and that's composite functions.